All right. I believe we're now live, and welcome everyone back to our 1:45 p.m.-ish panel on 6 gigahertz industry proposals. I'm going to introduce, we're going to have Mark Gibson, then Dr. Tom Willis, then Mike Mulcay in that order. And just want to give everyone's bio at the top, and we'll run from there. So we'll start with in speaking order. So Mark has over 38 years of spectrum management experience. He's responsible for developing domestic and international business opportunities for CommScope, in addition to leading technical and business development efforts for numerous wireless and spectrum-related products and services. He has led efforts to address spectrum sharing between the federal government and commercial users. He leads CommScope's CBRS efforts on the spectrum access system and environmental sensing capability sectors, and the efforts to develop, test, and certify the automated frequency coordination system for 6 gigahertz unlicensed bands. He is a board member of the CBRS Alliance and an officer on the board of the Wireless Innovation Forum. He is a member of the Commerce Spectrum Management Advisory Committee, where he has also co-chaired working groups related to spectrum sharing and data exchange issues, and has testified before the U.S. Congress on spectrum-related matters. He has led spectrum management efforts, including spectrum sharing analysis protocols and sharing criteria, as well as development of engineering services and software products. He speaks frequently and has authored several papers on spectrum sharing and relocation, and has advised numerous wireless participants in their system design. He's a life member of IEEE. He has an amateur radio license and is an instrument-rated commercial pilot. And he is a familiar face here at NSMA, where he's presented multiple times as well. So welcome aboard, Mark.
Thanks, Joe.
And we also are pleased to have our fellow board member, Dr. Tom Willis, who works in the area of microwave wireless communications at AT&T Laboratories in Middletown, New Jersey. He holds a PhD in electrical engineering, specializing in electromagnetics from the University of Michigan, Ann Arbor. Dr. Willis has served as the chair of NSMA Working Group 2 on over-the-horizon propagation loss. And again, as mentioned, he's a currently member of our board. We're proud to have him. And he's currently representing AT&T as well in the WindForm 6 gigahertz effort. Welcome aboard, Dr. Tom. And finally, and not least, we have Mike Mulcay, who I've known for decades. Mike's as chairman and CTO of ENCINA Corporation, Communications Corporation, is over 40 years experience in the microwave industry, including fixed microwave equipment design, technical marketing, and executive management. In the 1990s, as vice president of business development at Western Multiplex Corporation, he successfully petitioned the FCC for a rulemaking to allow unlicensed spread spectrum radios to operate in the 2.4 gigahertz and 5.8 gigahertz ISM bands. Since 2018, he's been one of the top 3 authors, filing in docket 18-295, where he petitioned against the use of unlicensed APs operating indoors in the licensed 6 gigahertz band without AFC. Mike is a fellow at the Institute of Engineering Technology and a senior member of the IEEE. And way back in the day when he was doing that Western Multiplex work, I was an associate at Keller and Heckman and did work for Mike way back then. So welcome aboard, all of you. It's a pleasure to have. I know there's a lot of keen interest in 6 gigahertz. So without further ado, we'll turn to Mark Gibson and get the ball rolling.
Okay, thanks, Joe. So I think folks should be able to see the deck I've got. Although I've got some stuff on here I got to get out of the way. Okay, so I have a fairly large deck for the time allotted. What I wanted to do was backload a lot of the AFC information, but spend some time just sort of setting things up. Here's the topics we're going to cover, and we'll just get right into it. So one thing to note about the 6 gigahertz band is that this is the largest allocation for unlicensed ever, 1200 megahertz, which made everybody in the unlicensed community very happy. Other parts of the world were only allocating the lower 500, 800 megahertz, or 850 megahertz, or 800 megahertz. But most of other parts of the world have done 1200, so have we. So that's a big deal. However, at least in the United States, this spectrum is populated by many incumbents, and you can just see this is at least all of the services represented in the band, going from fixed satellite, fixed microwave, fixed mobile, and then the passive services. And so all of these are treated as incumbents in the band, and we'll talk about how the AFC is supposed to protect them. So here we are again. And basically, the only thing I did was added the unlicensed folks here at the bottom. So we have all of the fixed satellite, fixed light, fixed microwave, mobile, and all that. We also now have the low power indoor, who can operate across the entire 1200 megahertz. And then the standard power, which can operate indoors and outdoor, that operate in the 5925 to 6425, and then 6525 to 6875, which are commonly called lower six and upper six. Although that doesn't accommodate the total upper six, or if you will, Uni 5 and Uni 7. So as you can see, there is a plethora of things with which to share, and we'll talk about that as we move forward. The power considerations, or the device considerations in the band, are really divided into three categories. The low power indoor, which it will not use the AFC, and there's all the information about that. It's fairly well known. What I did is characterize every type of device that the commission mentions in the rules as in the rulemaking. So under low power is the subordinate and client devices, and these could be, for example, things like, other than just things that work in the phone or whatnot, could be mesh extenders or Wi-Fi extenders in the house. Low power indoor, not on the AFC. The standard power, and that operates at maximum 1 watt. The standard power, which will operate on the AFC, maximum 4 watts, comprises a bunch of stuff that can operate, like I said, both indoors and outdoors. In the outdoor configurations, they could be for like fixed wireless access in a configuration similar to what you see here, which could be, for example, a WISP providing broadband to their customers, CPEs located within a coverage area, or just simply outdoor Wi-Fi, and many other flavors of unlicensed use in between. And again, I won't get into all these details other than there is a fixed client, which would be the CPE, and then the client, which is an indoor device. The other aspect of this is that these must be automatically geolocated, which there's a lot behind that I won't get into, but the device really needs to be able to tell its own location or have some capability to do that. Finally, and I think I heard this referred to in the DC panel with Evelyn Ramali and the other guy, talking about the status of very low power, and they were absolutely correct. The rulemaking hasn't completed yet. Right now, it's still simply an NPRM, and the main aspect of this is not just so much that this is very low power, but will accommodate mobility in devices as well. And you'll see here in a moment what the lack of mobility there, but for the NPRM, where they're still asking for whether or not devices can be allowed to move around. Right now they're fixed. And here, for an example, is the prohibitions and limitations we have on the band as it is. So no operation on drilling platforms, ships, cars, trucks, trains, or on aircraft operating below 10,000 feet. On aircraft operating at or above 10,000 feet, you can operate low power. This is all for low power. The other limitation is for outdoor operation using a directional antenna. If there's any up tilt in that antenna beyond 30 degrees, you have to, above the horizon, you have to limit the ERP in that direction to 21 dBm. That's so that you don't interfere with the airborne part of the satellites. So those are the limitations. Many of those are hoping to be removed by that NPRM I spoke about. Probably can't see this from just quickly looking, but what this slide tries to do is identify the number of microwave systems that are in the bands that needed to be shared with. Most of the folks that participate in NSMA are microwave experts, so I don't need to tell you what all of this comprises, but suffice it to say that there's over probably 50,000 links that are part of this, and over 100,000 frequencies. So sharing is a big deal, and that's what the AFC is all about. Here's a map of all that. And I put this up here mostly, again, you have seen our maps before, but mostly to just show that there's some folks that think, because if you look at, say, this map, or even maybe this map in certain areas, you see all this white space. So that means sharing should be easy. And the idea is possibly true, maybe in some cases, but when you look in very dense downtown cores, there is a very high density of microwave. And here's an example of the two band plans, the microwave band plan, which has 10, 30, and 60 meg primarily wide channels, and then the Wi-Fi band plan, which has 20, 40, 80, and 160, and even perhaps 320 meg channels. So it's not hard to envision a situation in a very dense downtown area where we have a lot of maybe 30 meg and maybe some 60 meg wide channels that could take out a fair amount of the spectrum if we don't have an easy way to manage it. Again, that's what the AFC is for. This shows, based on data in the ULS, the distribution of emission bandwidths. And so by far, the 30 meg channels are the most used. But we also have 60 meg channels. And those may be non-standard, but there are a lot of channel bandwidths. Again, like I said, the most are 30 meg. And you see it's well over several thousand. This is across the entire 6 gig band. So I didn't parse it by virtue of just the unibands we're of interest in. So that's just, kind of interesting. And again, this is a slide to show who uses the band by basically service type. And you can see the state and local government folks are using it for a lot of public safety and life and mission critical type applications, but so is everybody else. And so this again just shows how it breaks down and why there's such interest here. So here's the AFC, and we'll spend some more time talking about this. So basically what the AFC does, it processes requests for spectrum from devices, analyzes those requests based on data from the FCC's ULS, and then tells the device what spectrum is available and what powers it can operate on based on where it's located. So that's basically it. Seems pretty simple. Couple of other aspects of it is that the devices must contact the AFC once a day. If they fail to contact the AFC in any 24-hour period, then they have another 24 hours to contact it. So basically they have 48 hours to operate before contacting the AFC. But after 48 hours, if they don't, they have to shut down. The AFC has to store all of this information for 3 months. That's to help effectuate enforcement activity. Another thing the AFC will do is to verify that the devices are authentic. In other words, it checks the serial number of the device and the FCC ID. Serial number indicates that it belongs to a certified vendor. A device is certified itself, and then the FCC ID also confirms that. Like I said, the devices have to self-geolocate. Not enough time to get into the nuances of that, but suffice it to say they have to self-geolocate in X and Y, but an installer can provide the Z-axis or height. And the other thing too is, unlike CBRS, AFCs do not share information with each other with respect to the spectrum that they provided. So each AFC is autonomous and they are stateless, which means that there's no information on the AFC regarding what channel an access point is actually operating on. So these are some of the things that make the AFC much simpler. Here is how the guts of the AFC work to determine what it's supposed to do. Propagation modeling, Dr. Tom has been ingrained and entwined in that, in the WinForm working and in the normal work he does, and is an expert in that. But these are the models that we're supposed to use based on the FCC. And then in order to accommodate clutter, which is, trees and stuff like that on the interfering path, we have clutter models we use. The other key aspect of the determination is an interference protection criteria, which is basically a threshold degradation of 6 dB below noise. And there's no power aggregation at all. So we're really looking at this based on a single RLAN device. And so that's basically how the AFC works. There's a lot more to it. Obviously, if you participate in a lot of the standards committees going on there, you can tell, but it's really very basic. We also have to protect radio astronomy. Here are the radio astronomy sites. There's not that many of them, but they do require protection, and the protection is based on threshold or on distance to the radio horizon, which is a combination of heights and whatnot. So again, that's another thing we have to protect. Here is the messaging protocol, and actually I showed this to compare to CBRS, the SAS. So there are 12 messages that have to go for any specific operation of a device. For SAS, for AFC, there's 3. And I won't get into the details of this. There's not really a lot of time. You'll get this in the deck when you see it. But as you can see, it could be even as few as 2, because you can actually put the spectrum inquiry request on your device registration request, and you get your response. So it's much more simple and should be much easier to install and implement. There are right now 13 AFC providers that are waiting for the commission to tell us when. There were 14, but Amdocs pulled their application. These AFCs that are in the green yellow box are AFCs that are using something called the Open AFC, which was a concept that was pioneered by Meta, formerly Facebook, in their telecom infra project program called TIP, where they developed this AFC and they're actually making it available to these companies to use for free. But the companies actually have to commercialize it, get it tested, and support it. So, and I've just called that out because these all folks will be using the same kernel. What everybody's probably been waiting for is, what is the certification status? As far as I know, and I'll just speak for myself and my communications with the FCC, we're expecting that this conditional order to approve AFC should happen anytime. in the next couple of weeks, we hope. We're at the stage now where we're waiting to get into public trials and testing. There's been a lot of discussion in the standards development organizations on testing. And so we're trying to get that testing stood up. The next step after testing then would be public trial and demonstration projects. We think that those could be conducted in parallel. If not, certainly the public trial and demonstration projects to be conducted in parallel after the testing is completed. But anyhow, we're waiting for the public notice that should identify the AFCs that can move forward, as well as the protocols after that for testing. They'll get tested. We'll provide our reports to the commission. And then sometime by the end of the year, we expect AFCs to be finally certified. I don't really have time to get into what's going on in the various standards development organizations. Here's who they are. There's the Wind Forum, Wi-Fi Alliance, and then there's a multi-stakeholder group. The Wind Forum and the Wi-Fi Alliance are standards development organizations. The multi-stakeholder group is a group of folks that have interest in this, that are participating in trying primarily to deal with how you address harmful interference detection, reporting, and resolution. And with that, actually, here's the international. I cribbed this out of the Wi-Fi Alliance, and so those links are live in case anybody wants to go and click on the various country. I did not break out the European Union. There's some other nuances there, but that's what's going on internationally. And it's surprised to say that there's many international NRAs or regulators that are looking at AFCs. So with that, I'll turn it back to you, Joe, to give to Tom. Thank you very much, and we can do questions later.
Wow, you put a lot in there. Sardines are lined up in the can quite well.
Yeah, I know.
Good job. Good job. Yeah, really good. I highly encourage everyone to review these PDFs and the video once they're posted. There's a lot there to use as a resource. So thanks, Mark. So we'll turn next to Dr. Tom Willis of AT&T. And your mic is muted currently. There we go.
Okay. Are you seeing my slides okay, Joe?
Yes, you did a good job.
All right. All right, everyone. Welcome welcome to NSMA 2022. Good afternoon, everyone. My talk is nowhere near as dense in material as you just saw from Mark's, but I was hoping to sort of just give a high-level overview of the work that's been going on in the 6 gigahertz band. For those of you who may not be familiar with it, for those of you that are familiar with it, the good news is I only have 4 slides. So in any case, all of this really became real and kicked off about 2 years ago when the FCC issued a report and order of April 2020, which actually permitted the use of unlicensed devices in the 6 gigahertz band. And there are some new Part 15.407 rules that discuss this. Those rules basically look at 2 types of devices. There are low power indoor use devices, as well as standard power devices, which must be controlled by an AFC. The low power indoor devices are available today. I mean, you can go to your favorite electronics retailer and buy yourself a Wi-Fi 6E device and take it home and turn it on and use it. So those are out and starting to be deployed out in the field today. The standard power devices, which are under AFC control, are not out yet today because we still are working on getting AFC systems set up and running, as Mark described. As Mark described, just want to reiterate that this is 1200 megahertz of spectrum. That spectrum is divided into 4 bands. There's the lowest 500 megahertz, which is the Uni 5 band. For folks that have been in the fixed service microwave arena for a while, this was traditionally known as the lower 6 gigahertz band. Then there's another 100 megahertz chunk of spectrum, the Uni 6, and then followed by another 350 megahertz spectrum, a chunk of spectrum, the Uni 7, and then the remainder is Uni 8. And again, the Uni 7 band, if you've been in this business a while, the fixed service microwave business a while, like myself, that's sort of traditionally been known as the upper 6 gigahertz band. So all of those bands are available to the low power indoor devices, but the standard power AFC controlled devices are going to be operating in the Uni 5 and Uni 7 bands only. Part of the report and order that came out a couple of years ago, the FCC requested or mandated that there be a 6 gigahertz multi-stakeholder group formed. And the language from the report and order was to address issues specific to technical and operational issues associated with AFC system. And so basically anyone that has an interest in the goings on at 6 gigahertz has been invited to participate in that multi-stakeholder group. And I'm going to spend just a little bit of time in the next few slides discussing what's going on there. If I go to this next slide, this again is from the rules, and it relates to the power limits that are permitted for the various devices. And you can see that the standard power devices on the upper 2 rows of this chart, both the access points and their associated clients, are granted larger power spectral density limits than the low power indoor devices, which again, there's other restrictions on those low power indoor devices, such as they can't be battery operated. They have to be, plugged into a wall outlet somewhere to get power. They're not supposed to be weatherproof, so they're not designed to go outdoors. So that the idea is that these things would only be used indoors and at these lower power levels, and as such would not need to be controlled by an AFC system. But with the formation of the multi-stakeholder group to look at the issues associated with the AFC system, there's sort of been some organizations that have gotten involved with this. There is a multi-stakeholder group. There are 3 work streams in the multi-stakeholder group, as I show on the left side of this slide. But in addition, there are some standards development organizations, the Wi-Fi Alliance, as well as the WIN Forum that have gotten engaged in this effort. I'm personally involved with the WIN Forum on this effort, and sort of the current working groups and task groups within the WIN Forum are shown in the graphic here. There's also the Wi-Fi Alliance is engaged in this, and the 2 organizations sort of need to stay in sync with each other. So there is a liaison agreement between the 2 organizations, and they're able to trade documents back and forth to sort of, hopefully divvy up the work as to who's going to address what, and to make sure we don't have any conflicts. But again, those documents need to be negotiated back and forth between the 2 organizations. So that's sort of at a high level what's been set up, and the people that are working in this area are engaged in one or more of these organizations you'll see on this chart here. And there is, my last slide, there is mission statement for the 3 work streams within the 6 gigahertz multi-stakeholder group. Work stream 1 is primarily responsible for looking at harmful interference detection, reporting, and resolution, and they're working on a document to basically highlight industry best practices and how folks that have been participating in that organization feel that should move forward. That document is very close to being completed at this point. The final comments were due on it earlier this month, and those comments are being integrated by the workstream chairs. And once that work is finished, which is eminent at this point, it will go up to the multi-stakeholder chairs themselves to take a look at, and at some point it'll be released as a document. There's also work going on in workstream 2 on making sure that there's good incumbent data. I mean, the FCC ULS database is mandated by the FCC to be used in doing the AFC interference calculations. You have to look at who's out there to know who you might be interfering with. There's a lot of work in this also going on in the WIN Forum. And there's workstream 3 is also there in the multi-stakeholder group looking at the AFC development and implementation. And again, there's work in the WIN Forum in this topic as well. So I guess just as a parting comment here, I would say that anyone in the audience that has an interest in the 6 gigahertz band, either as an incumbent or as a potential new unlicensed user, so I would encourage highly to get involved in the multi-stakeholder group and or the WIN Forum and Wi-Fi Alliance. AT&T, of course, has an interest here because AT&T is always looking at new communications technologies that become available for potential use in our network. The unlicensed 6 gigahertz devices are no exception to that. And in addition, AT&T does have a fairly extensive incumbent 6 gigahertz point-to-point network out there. And so we are also concerned about the performance of that network and how it's going to play with the unlicensed devices. So I think that kind of wraps up my set of slides there, Joe. I'm going to turn it back to you and be willing to take questions at some point.
Great, Tom. Thank you. Crisply stated, good information there as well. One thought is perhaps we put the coordinates in the chat of where to go if somebody wants to join one or more of the alliances, websites, phone numbers, emails. If anyone has that at their fingertips, that'd be great. All right. And we are on to Mike Mulcay.
Okay. Appreciate it, Joe. Do we, how do I get rid of these guys and get my slide press up?
You at the very bottom, if you just put your cursor at the right below your face there, you'll
Yes,
see share screen.
Thank you.
There you go. Live the dream.
And there we go. Almost. Hang on. Come on. There you go. Okay. A lot of, well, yeah, a fair amount of what I'm going to cover was covered by Mark and some of it by Tom. So bear with us on that. So what we're going to talk about is unlicensed use of the 6 gig band, the problems as we see them, the solution as we see them, field trial evidence that supports our petition to the FCC, updating the rules basically, and harmonizing the rules, and then the benefits, summary, and a few Q&A questions, just in case people don't ask them. We thought we'd bring them up and then we can, do a general Q&A. So on April 24, 2020, Commission released a report and order and a notice of proposed rulemaking authorizing AFC, coordinated unlicensed outdoor standard power access points and their client devices to operate in that band. So the rules as stated in the report and order allows the use of outdoor standard power devices provided they are coordinated with AFC. Problems as we see it, while none of the Part 15 rules are the same as the Part 101 rules, the FC interference protection criteria 15407 is the same as that as 101-105. Basically, it's that if an AP network coordinates, it coordinates. It doesn't matter about the individual parameters. Does it or does it not coordinate? So when the Commission approves an AFC system, if the AFC system does not meet Part 15407, which is the interference level of 6 dB below thermal noise, the results will be ever-increasing harmful interference to existing fixed service stations and ever-increasing intra-AP interference, which creates dirty air, which is the same as sub-6 unlicensed 6 gig bands. And even if fixed wireless operators object to the AFC's inadequate interference protection and file suit in federal court, they will lose because the precedent says that if the court has to choose between FCC engineers and fixed wireless engineers, the court's going to rule in favor of FCC. And 3, we believe that this will put at risk all licensed 6 gigahertz fixed links and dramatically reduce the market size for members of the National Spectrum Managers, because people aren't going to want to deploy high reliability 6 gig links if it's subject to interference. So it's critical, we believe, that AFC meets its stated objective, 6 dB below thermal noise. So why are we looking to suggest updating Part 101 rules to harmonize with Part 15 rules in the 6 gig band? Well, late in 2020, ECC asked the Commission for experimental licenses for Marina, California and Portland, Maine. to investigate flexible use of mid-band spectrum in the 5964 band. And the reason we picked that was that there is off-the-shelf equipment that could do that. And how we could do that while ensuring that licensed services operating in the band continue to thrive. The Commission issued experimental licenses for both cities or towns. They were issued, and in order to protect existing and pending incumbents, the Commission required ECC to, quote, coordinate with the fixed microwave service licensees in the proposed venues in accordance with 47 CFR Part 101, 103D prior to operating. And the Commission said, you do that, it'll be safe. So we said, okay. So we engineered networks for both cities, issued prior coordination notices for the proposed experimental microwave systems to the owners or their designated agents of all existing or proposed terrestrial and satellite facilities potentially affected by the proposed system. In the PCM, we stated that the radio frequency studies were based on TIA-10, or formerly TSB-10F, and using standard engineering practices. We did that for the reference systems, and that the APs, along with their fixed and mobile clients, can operate within a 5-mile radius of the AP without causing harmful interference. The PCMs ultimately cleared. No interference cases were left open. So in February 22, we took an unlicensed sub-6 network operating multiple underserved clients in Marina, and through the click of a mouse, we moved it up into the 6 gig band. And as expected, no cases of interference have been reported, and it's still working perfectly. It's a really quick, easy switch, no interference at all. So what we did, we petitioned on March 24, 2022, the Commission to update Part 101 and to harmonize it with Part 15. Specifically, and I broke it out here from the actual filing, we said that it only requires minor changes to Part 101 rules to update and harmonize. One, add the definition of access point and client device, which is given in 15403, add it to 101.3, and that's just defining what it is. And then in 101.115B, in the antenna standards table, add a new reference, 16, to frequencies 5925 to 6425 and 6425 to 6875. And add a new footnote, 16, as follows. There's 15 footnotes already. So the 16th footnote would say APs and their client devices are permitted to use any type of antenna, directional, sector, or omnidirectional. This actually is in line with 101.115, except that 101.115 says that you can use any type of antenna, including sector and omnidirectional, but because it isn't under 101.115B, there is no radiation pattern envelope, you need to ask permission. Well, the point being, if the rules as presented by the Commission for Unlicensed Devices says, if a device coordinates, that's it, it coordinates, then we thought that was quite a reasonable thing to say. So the benefits of updating Part 101 to harmonize with Part 15. By updating Part 101 rules to harmonize Part 15, the 6 gig band, outdoor standard power APs can be licensed, resulting in the following benefits for consumer and industry. By prior coordinating 101, 103B, industry is assured that licensed APs will not interfere with existing fixed license stations. I mean, it's just treating an access point like any fixed station, except it's called an access point, and is allowed to be unlicensed as well. Two, new fixed license applicants know where all the APs are located. If there's a potential interference problem with a new applicant, if the new applicant is using a category A antenna, the AP operator must mitigate the interference problem. That's no change in the rules. Three, it allows for immediate deployment of off-the-shelf, low-cost, high-performance, gigahertz speed AP networks, solving the last mile problem and thereby helping close the digital divide. Four, it preserves clean air spectrum, since licensed APs can be synchronized with each other, whereas unlicensed APs are uncoordinated with each other, basically causing dirty air, then you end up with the same problem you have with subset. Five, licensed APs have priority over unlicensed APs. And six, a significant opportunity for members of the National Spectrum Management Association to dramatically increase revenue and profits. In other words, you don't lose business, you can just gain business. And so in sort of summary, there's nothing that can be done to overturn the April 2020 report and order authorizing AFC coordinated unlicensed outdoor standard power access points and their client devices from operating in the 5964 and 6568 license bands pursuant to Rule 15407. That is, Part 15 devices are allowed to operate in license bands. When the Commission approves an AFC system, this is why it's critical. If the AFC does not meet the stated interference requirements, the result will be ever-increasing harmful interference to existing fixed service stations, and two, ever-increasing intra-AP interference, creating dirty air, the same as in the 6 gig bands, and significant decrease in the size of the 6 gig Part 101 frequency coordination market. And as we said before, even if there's an appeal to the courts, going to lose. So we believe that harmonizing Part 101 and Part 15 rules would mitigate the above problems. Just a few Q&A, just in case they wouldn't come up. Question, would updating Part 101 rules to harmonize with Part 15 rules increase the stature of unlicensed APs? The answer is no. Unlicensed devices are always secondary to licensed devices. Question, will licensed APs block new fixed link applications? Answer, no. APs licensed and unlicensed do not use category A antennas. Therefore, a new fixed license applicant using a Cat A antenna is primary, and AP operators must mitigate any interference problems. Why is coordination of APs using Rule 101 better than coordination of using AFC? Because by prior coordinating using 101-103, industry is assured that licensed AP networks will not interfere with existing fixed license station. And two, AFC has open technical and operational issues, and the date when those issues will be resolved is unknown. As Mark said, maybe the end of the year, who knows? Also, it's not known if AFC will meet the requirement of Rule 15407. Question, is FDD more spectrum efficient than TDD? No. APs operating in the 6 gig band will normally operate FDD TDMA, where the peak download or upload speed can be twice that of FDD, and the number of paths can be many compared to a single path. And will AFC system operators' fees be less than Part 101 frequency coordinator and FCC licensing fees? The answer is no. Part 101 prior coordination and licensing charges are a one-time event, and therefore they're a balance sheet item. The monthly cost per client will be the one-time charges divided by the term of the license times the number of clients served per AP per month. And this will result in a cost of a few cents per month. Also, service providers with licensed APs can offer consumers Wi-Fi 6E hotspots with clean air and high speeds for the same monthly price as unlicensed Wi-Fi 6E with dirty air and lower speeds. So by capturing market share, licensed operators' additional revenue goes straight to the bottom line as profits. And again, we don't know what AFC operators will charge for their services, but we think it's got to be more than a few cents a month. And I think we're just about there. Do individual consumers need outdoor APs with AFC, and what is the size of the market? The answer is no. Consumers don't need outdoor APs with AFC. The markets and the market size is somewhere between small and none. And we conclude that because today, when individual consumers leave their home or office, they're connected to the internet via a service provider, not via a personal outdoor Wi-Fi AP. Therefore, that will be likewise the case for Wi-Fi 6E. And so that's about it. And if we get into any questions, be great. Thank you.
Thank you, Mike. So I think we've got an interesting group here. We've got athletes of 6 gigahertz, so to speak, super team. So I'll ask a couple of probably the obvious questions. I'm assuming from Mike's standpoint, why not just do this? This looks really simple. And on the other side of the coin, hey, isn't this pretty late in the game? We got all these systems ready to go. Why in the world would we even think about something else? So maybe some of you guys in whatever apparent order can address those two obvious questions. And there's probably other questions as well that'll pop up in the chat, but those are probably the two obvious ones.
Yeah, we're not saying you shouldn't continue with AFC, and if you can do AFC, that's great. If it meets the interference requirement, that's wonderful. And if you want to, for those people who want to have their own access points, that's great. You know, we're not against it. We would just, we're a WISP, by the way. We would just like to get to market sooner rather than later, and we don't see the need to wait.
All right. Mark, Dr. Tom, any ruminations?
Joe, I'd just like to point out that the low power indoor is two things. It's low power and it's indoor. If you're a consumer and you want to do high power indoor, you're still going to need the AFC system. So, I mean, I could see consumers, ultimately buying AFC controlled devices once those become available.
I think the only thing I would add
Mm-hmm.
is that the use cases that are contemplated for unlicensed operation of the band are fixed wireless access and much more, such that the I guess immediacy you get with an AFC type approach versus trying to do a Part 101 coordination, which requires 30 days and all of that stuff. It may lend itself better to a fixed wireless access type of an approach, but not really a dynamic approach where you've got buildings full of Wi-Fi access points that are all trying to be managed, say in a downtown area where the microwave environment can change, maybe not dynamically, but certainly can change in a 24-hour period.
And yeah, agreed with both guys.
So with that in mind, are we talking in either or a both and from everyone's standpoint?
Both.
So Mike is a both and Mark and Tom, do you guys have any thoughts as either or, both and, or reserve? You'll do a post-argument memorandum of authority later.
That's nice lawyer speak, Joe. I think I'll take the latter and just say that what's been codified in the rules for this band to support unlicensed operations is the AFC.
Yeah.
Yeah, I'd have to agree with Mark there. I mean, and AT&T doesn't really have any official position on Mike's proposal, so I can't really add much to that.
Yeah.
All right, fair enough. Fair enough. Very intriguing, though, I gotta say. And we've run a couple minutes over the wire. We have Dr. Jordan Girth with scientific and meteorological use of spectrum coming up. I would say, though, this, there's a lot of keen interest, as we talked about at the top, in this topic, and love to see this continued. Obviously, there's 3 other forums for it, but NSMA, we look at this very, very routinely. As Tom mentioned, we're very focused on the incumbent licensees. These are mission critical licensees. We're talking state police backhaul. We're talking, AT&T, Verizon backhaul, utilities, major dams are opening and shutting at them. So, we're not, these are, this is not a measure twice, cut once. This is like a measure 1,000 times, cut once kind of game we're in with 6 gigs. So, I guess one other thing that came up, I know we're a little over, but maybe if there's a quick answer to it is there an appetite for full scale, very targeted physical tests where everyone can get empirical data? And is there a budget for that? At INL and Idaho National Labs, or we heard about Cherry Point, North Carolina, from the Navy a moment ago, and there's other spots. Is there a full scale test bed that's well funded, or we think could be funded to really game these things out without putting the whole country into an experimental mode?
Well, I can comment on that. As part of, I think I mentioned this in my deck, as part of the approval process, the commission is anticipating for each AFC what they're calling a demonstration project. And, theoretically, that's a field trial where you deploy devices in a controlled environment, work collaboratively with the incumbent community, and give them actually opportunity to comment on what you're doing, and then effectuate any changes that need to be made accordingly. Very similar to what we did with CBRS, which was what we call initial commercial deployment, ICD. And even we did this in TV whitespace. In terms of a much more in-depth measurement program, I would suggest that there's a great measurement lab, ITS. They're probably the best at what they do, but they need to be funded. So, industry could work on a CRADA, which stands for Cooperative Research and Development Agreement, working with them. They did a lot of testing in CBRS. Whether they're thinking about anything here, I don't know. But to the extent that anybody wants something where you've got a neutral third party that has probably the best metrology you'll find anywhere, I would approach them. Right now, Eric Nelson is the acting head, so that's something you might think about.
All right. So, because to me, that'd be very constructive if there was a way to get to a CRADA or some sort of funding, nirvana, and get, so we could all see the data, everyone could get comfortable, or everyone could say, like on the preschool playground, see.
And just jumping in, Joe, our point is that we know that 101, 103 prior coordination works. It's worked for 40 years and it continues to work. The question only is, if it coordinates, it coordinates. If it doesn't, everybody who's potentially at risk gets the chance to call it. And if it doesn't coordinate, you don't use it.
Yeah, very intriguing. You've never been a boring person, Mike Mulcay, and you're not going to lose that crown today. So.
Okay.
All right. I know we're 6 minutes over. We have to get to the next, but this is very, very useful. What a pleasure. And hopefully we can continue the dialogue, everyone. Thank you so much.
Thanks, everybody.
Okay, appreciate it, guys. Bye-bye.
Bye.
Thanks, Joe. Bye now.
Yeah.